Hello everyone, this is Nitesh Kumar and welcome to Nitesh Labs. In this video, I am going to discuss about the design and development of landmine detection robot. This robot can be very useful as a final year project for engineering students. This robot helps in detecting buried landmines in an infested field. Thus can be projected as a military robot. This robot is controlled wirelessly through RF transmitter. The controlling range of the robot is 100 meter. Please feel free to contact me for any of your queries. You can reach me through my mail ID or by commenting in the comment section. My mail ID is niteshkumar027@gmail.com. This complete system consists of 3 parts. First, transmitter card, second, receiver card, and third, mechanical body. I will deal in detail with the design and development of both the cards, transmitter card and receiver card. Mechanical body design can be created with the help of local hardware store. The effective range of controlling this robot is 100 meter. This robot can be used for detection of landmines or any suspicious underground materials. Working video of the robot is put at the last. All the necessary files and code is provided for downloads. I also request you to please share this video to your friends. This is the complete schematic of landmine detector RF transmitter card. This is the 8-channel RF transmitter card. The major component of the card are 433 MHz RF transmitter 1, LM7L05 voltage regulator 1, ST12V decoder IC1, some resistors, LEDs, diodes and push button switches. When a particular switch is pressed, the ST12E encoder generates encoded signal and that signal is transmitted via RF module. These are the switches which are placed over here. When the switches are pressed, they are connected to the ST12E encoder IC. So when a particular switch is pressed, an encoded signal is generated and that signal is being fed to the RF module, and then it is then through the RF module it is being transmitted, which then receiver receives it. The circuit uses totally 8 push button switches, as you can see, 1 2 3 4 5 6 7 8. Four switches are used for moving the robotic vehicle forward, backward, right and left. These 4 switches, 1 2 3 and 4, these 4 are arranged on the PCB in such a way that they are being used for controlling the robotic vehicle forward, backward, right and left. The other two are used for moving the detector arm clockwise and anti-clockwise. These 2 switches, when pressed, they helps in rotating the detector arm in a clockwise and anti-clockwise direction. Left or two buttons are kept spare. These 2 are kept spare. When you press this switches, definitely a signal is generated and then being communicated and being received at the receiver end. The port is left open or blank. You can connect any other different gear or different motor parts or any robotics parts to control accordingly as you wish. Once you are done with the schematic, it's time to go for the layout. You can use any of the design software you want. Here I am using Design Spark. This is the complete board layout design. It is a two-layer card, top layer and bottom layer. The length of the card is 104 mm and the width of the card is 74 mm. Now let us look at the placement of the components. Here it comes. I have placed almost all the component on the top layer, so there won't be much difficulty in getting the placement done. You can use different approach, but the one which I have used is here. Toward the this is the place where I am this is the place where I put the connector, where I am installing RF module. This is a SMA connector which is put over here, where you can place the external antenna. This is the place where ST12V encoder IC is placed. At the top I have placed LM705 voltage regulator. Here I have placed two box tips for giving input to this card or to this LM705 voltage regulator. We can put 9 volt or 12 volt, whatever we want here. Generally we put a 9 volt battery because that is smaller in size. And these are the associated resistors which particularly helps ST12V in completing its functionalities. These are the four switches positioned in such a way that the top one, when you press, you get your vehicle moving in the forward direction. If you place the bottom one, you get your robotic vehicle moving in the backward direction. When you press the right button, you make your robotic vehicle to turn right, and when you push the left button, you make the robotic vehicle to move in the left direction. So that's why they are placed in such a way, so that it becomes easy when you are accessing your robot. At the bottom you can see there are four other switches are placed. These four switches are placed in such a way, or when you press this particular switch, you can add different functionalities as you want. As now here I have attached an arm where I have put where I have attached a sensor, metal detector sensor, and that arm I am able to I am rotating in a clockwise and anti-clockwise direction. So when I am pressing this particular buttons U5 and U6, I am able to rotate the arm in a clockwise and anti-clockwise direction. Two other buttons are left open, although when you press the signal when you press the button, signal will be generated at the receiver end card, but that is not utilized. You can utilize those to run different motor on your robot and get different functional get some different function done. So this is the complete layout. At the bottom you can find these are the diodes which are placed. So this is all about the layout. Now let us see the top layer of the card. This is the complete top layer of the card after routing. Now let us see only the bottom layer. Okay, here it comes. This is the complete bottom layer. Now let us see complete board once at a time. Yes, here it comes. This is the complete board with the both top and the bottom layer. Now let us generate a 3D view and see how it looks over there. So this I have already generated. I'll just let's remove this and I'll generate once again for you. Okay, here it comes 3D, yeah, 3D view. So this is how it looks when you generate a 3D view. It gives you a complete picture, how means how the board will look alike when you fabricate the board, something like this is the top layer and this is the bottom layer of the card. That's it. This is the complete schematic of Landmine Detector robot receiver card. The major components are one ST12D decoder IC, one RF receiver 433 MHz, two L293D motor driver IC, one Atmega 328P microcontroller, one 16 MHz crystal, one Arduino Nano board, one LM705 voltage regulator, few terminal blocks, and some resistor capacitors and LED indicators. See, the schematic is divided into 5 different blocks. The first block deals with the receiver section. The second block deals with the microcontroller section. The third block is a motor driver section. The fourth block also is a motor driver section, and the fifth block is the microcontroller Arduino Nano section. Now let us try to understand in detail how the signal flows. As you can see, this is the first block, which is the RF receiver section. The major component of this block is ST12V decoder and RF receiver. The RF receiver receives the signal which is being transmitted by the transmitter, then feeds that signal to the ST12D decoder. The ST12D decoder decodes the signal and then passes that signal to the microcontroller section. Here Atmega 328P is used as a microcontroller, thus you can use Arduino platform to code this particular microcontroller. This controller receives the signal from the ST12D decoder, and then based on our code what we are writing over here, it produces the output. The output produced helps us in controlling the two motor drivers which are placed at the bottom. This is third block. The third block deals with the motor driver section. Let me have it a very clear view for you. Yes, this is the third block. This is the motor driver section. This motor driver section consists of mainly L293D motor driver IC and LM7805 voltage regulator IC. This LM7805 is connected here in this particular schematic in such a way that it provides power to all the ICs which are present in this schematic. The motor drivers, this motor driver is run by after getting the signal from the microcontroller, which in turn drives the robot forward, backward, left or right. One motor driver IC is capable of driving only two motors. So for controlling the arm on which we have placed the metal detector, we need another motor driver IC. So that is why we have placed two motor driver IC. The second motor driver IC, which is the fourth block here, this motor driver IC is also capable of driving two motors. So The one through one port we are driving a arm motor which is swinging left to right and right to left, and thus scanning the ground with the help of metal detector attached to it. The other motor port is left open. This is up to you if you want to use this port and connect some other motors for controlling camera movement or some other thing. You can do so. This is the fifth block. This is the Arduino Nano block. So we have put the provision that if you are not able to get the Atmega 328P microcontroller from the market, you can directly insert the Arduino Nano board. You have to program, you can program it through Arduino IDE, and then after coding that, you can just insert that particular Arduino Nano board into the board and solder it, and thus get your work done. So basically you need either of them. Either you need Atmega 328P microcontroller or you need Arduino Nano. So in the schematic or in the board we have made the provision for both, so it is up to you. Whichever you feel comfortable, you can go with that. So this is all about the schematic. Once you are done with the schematic, it's time to go for the layout. You can use any of the PCB design software you want or you are comfortable with. Here I am using Design Spark for my convenience. This is the complete layout of the receiver card. Now let us look at the placement of the components. So let me hide the layers. Sorry. Yes, this is a clear picture of the layout of the component or the placement of the component where we are placing the major components. Almost all the components are placed on the top layer, as you can see. This section I have placed the receiver, 433 MHz RF receiver. Next to the receiver is ST12D decoder IC with all its associated resistors and capacitors and LEDs. Okay. Next to the ST12B decoder, I have placed the Atmega 328P microcontroller with its associated component just beside them. At the bottom of this Atmega 328P, I have put the Arduino Nano board. We kept a provision that we can use either of them. So both of this Atmega 328P and Arduino Nano are connected in parallel. So you can use any one of them. Just toward the leftmost corner, I have placed the two L293D driver ICs, motor driver ICs, and just below that, these are the blocks through which we are running the motors. As you can see, this is the space kept for motor 1, motor 2, motor 3 and motor 4. This is the LM7L05 voltage regulator, and this is the terminal block through which we are feeding the 12 volt power. From this 12 volt power is being fed to the LM7L05 voltage regulator, which in turn generates 5 volt, and this 5 volt is being supplied to this ST12D, this RF receiver, Arduino Nano, this Atmega 328P microcontroller and Arduino Nano boards. So it supplies the power everywhere. Now let us look at only the top layer of the card. This is the top layer of the card, or with the top layer of routing. It looks something like this. Now let me show you only the bottom layer. So just hide this. So this is the bottom layer routing, This is a 2-layer card. Now let us see all complete card once again. This is the complete routing of the card with the top and bottom layer. Routing depends upon your efficiency, how you route it. That cannot be explained here. Although the gerber file is attached for you to download, where you can download the gerber file and directly give it for printing. That is available here. This is the connector which is put SMA connector, through which you can put the antenna if you want, or you can just put a wire simply. But here I have put SMA connector, so that if you want you can put the 433 megahertz RF antenna also over here. Now let us see the complete board in 3D. Let us generate a 3D view. Going to this, and this becomes a 3D view of the card. After generating, the card looks something like this. This is the top layer, and this is the bottom layer. You just need to feed the power, put the code, and extract the output from this motor driver ICs. Coming to the mechanical design of the robot, the mechanical body of the robot consists of two parts. First one is the robotic platform, and the second one is the rotatable arm. Let us first understand the robotics platform. The robotic platform looks something like this in my case. This robotic platform can be created using an acrylic sheet or any other metallic chassis available in the market. You need to fix 200 rpm 12 volt DC gear motor at the rear end with 4-wheel arrangement as shown in the picture. The base plate need to be kept longer for fixing the rotatable arm structure. I have also placed a top plate. This serves dual function for me. It protects the electronic circuit. Second, it provides a base for keeping the battery. Although this is an optional plate, you can put or you cannot put, but it enhances the beauty. The second part of the mechanical structure is the rotatable arm. Here in this image, the red mounted structure constitutes the rotatable arm. It consists of a 12 volt 30 rpm DC gear motor with its shaft coupled to a rod which is welded to inner ring of the bearing. A L-shaped metal is attached to the extended motor shaft on which metal detector sensor is mounted. The outer ring of the bearing gets welded to 4 small iron strips through which the structure rests on the base plate. The motor remains within the mechanical frame. The whole arrangement can be understood with the picture which is present over here. Now let us see the working of the robot. This is a complete working design of the robot. This is the remote through which I am controlling the robot. I am swinging the robotic arm left and right. A dummy metal pieces are kept on the ground so that whenever it detects, it gives me a beep sound. So now the robot is scanning, and as soon as it will encounter the metallic part, it will give you a beep sound. Here it comes. It has detected it. So this is how whenever it will encounter any metal or it will scan any metal, the buzzer attached to the sensor will give you a beep sound, and thus you will come to know that there are some suspicious or landmine beneath that ground. This is how we are scanning it. We are rotating the arm towards left and right and moving the vehicle front, back, left and right. Thank you for watching. This was a short video on design and development of RF based landmine detector robot. All the necessary files and Gerber files are provided for download. If you want to build the project, all the necessary files are available for downloads. I also request you to please share the video so that it reaches the people who are actually looking for such kind of videos, like robotic enthusiast people, hobby electronics people, robotic group people, etc. Thank you.